All right. We switch a little bit the domain. We go into the domain of problem solving in technology-rich environments. And I worked here with the PIAAC data to find out more about the web search behaviors that people, showed in the PIAAC study. So web search is actually very interesting domain or a very interesting area because it presents us with a lot of information, with huge amounts of information, but of course we have limited time, limited cognitive resources. It becomes an allocation problem basically. So we have some theoretical ideas about how web search works, how we decide on which information to process and when to move on. And the basic idea here is that we differentiate between rather heuristic and rather systematic processing. So systematic processing would mean I go systematically through the information. I have a look at all the options. And as you may notice, this is not something which is exactly possible when we do web search because there's just this huge amount of information. So we rather engage in heuristic processing, which means we use a rule of thumbs to decide what to look at and where to put our concentration at. And this is often combined, or what we observe so far in the research literature is that this often comes together with strategies that we call satisficing, for example. So satisficing means once you have found something you find suitable, you stick to that particular information. Or another strategy that has been described is sampling. So sampling means you rather systematically process the information and you continue looking until you have found the presumably best option. So what I want to propose today to you is that we can actually use such theoretical considerations to derive a set of process indicators that describe certain groups we can differentiate based on such rule of thumbs. And what we did here is that we identified, or we assumed that web searchers or people who do web search would use a rule of thumb in terms of their search strategy. So if they rather focus predominantly on what they encounter on a search result page, or if they would rather use the information that they find on a website. A second rule that we use here, or that we assume here, is a stopping rule. So if people would rather tend to stop their decision process rather early, or if they take their time, go through more information, have a closer look, and therefore rather end their decision process late. What we investigate here now with the PIAAC-log data is that if we can actually, first of all, find such groups that we expect to find. So we differentiate here between that searching predominantly on the search result page or on the websites, and making rather quickly a decision or coming to it rather late. So these 4 patterns you just saw. We also investigated, but I will not go too much into detail about that, how consistently adults stick to such behaviors that we identify, since we have at least 2 items in the PIAAC study that provide such a web search situation. We also did some analyses on by what are determinants of such behaviors that we might find. And what I will go into more detail in today's talk about is that we also use these behaviors they identify to explain item success beyond information processing skills like reading and evaluation skills, but also certain background variables that have shown to be related to web search behavior in previous research. So coming to the method part, let's talk about a bit about the item material and what, especially about the sample we used here. You're probably all very familiar with the design of PIAAC, but just let me point out that the 2 items we used, so from the problem-solving domain, which is item U06B and U07, are actually items from different modules, which puts us in the uncomfortable situation that these items were not necessarily or always processed together. So we have, in fact, that leads, especially when we want to consider literacy as well, this leads basically to 3 independent samples. So to a sample where we actually have data of adults processing both problem-solving tasks. We have a second sample where people just had one of the problem-solving tasks and a literacy assessment, and then a third sample where we still have the literacy assessment, but people were given the other problem-solving task. As Artu already pointed out, I can't show you, of course, the original items, but at least I can show you a released item that very similar looked like what the original items were. And the first item, so U06B, also the so-called sprained ankle item, provides people with 5 links that they can click, and they can search, they can go on the next website, and also on some of the websites they can go even deeper. This item asks people about making a decision, or a decision about which one of the provided websites is the most reliable and the most useful in terms of solving a specific information problem about medical treatment. And also what you can see here on the slide is that for the 2 samples where this item was presented, solution rates are quite, at least descriptively, quite comparable. The second item is somewhat different, although it also presents a web search result page together with a number of websites that you can navigate to. Here we have, instead of 5, we have 6 clickable links, and the task instruction is very different, because here it's not so much about evaluating reliability of information, but about doing something and buying actually a product that matches a list of specific criteria. Having a look at the rates of correct responses, the rates look a little look still similar, but for some reason, especially in sample 3, the rate is a little bit lower descriptively. Okay, just to give you a quick glance at what variables we used from the PIAAC data. In terms of the process indicators, we came up with 4 indicators that should maximize or that kind of should maximize finding that we expect. So they were particularly chosen. So for example, in terms of the SE group, so the group that should predominantly rely on the information of the search and of the search page, and that should come fairly early, or rather early to a conclusion. Here we would, for example, expect that these should be people who show a low time on task, those who would spend more time on the search result page, so should have a rather high and positive SERP website time ratio. They probably visit very few websites, and they might show something that we call satisficing, or we built here a satisficing indicator, which would which we defined as showing that people picked the website as their response that they have visited last. And another particularity I want to mention here about that satisficing indicator is that it is also defined in terms of that people did not visited a website multiple times. So it's this indicator can only become 1 or express as satisficing if websites were only visited once, and if the website the response was visited last, which is also interesting for especially the second item, U07, but I will come to that later. Yeah, apart from that, we used the item scores from both items. We used the demographic variables, especially here the age and years, and a classification of educational attainment in low, medium, and high. We used a score, we used the reading literacy items and produced a WLE score. And we also created an evaluation skill score, although evaluation skills were not assessed directly, but we used a third item from the problem solving domain, recoded it a little bit, and came up with 2 indicators that would present how people's skill in evaluating the usefulness of online information and their ability in identifying exactly what kind of deficiency an information source might reveal. Okay. So here just the most important parts are that for now I will present results from a clustering where we used a partitioning around Madoid's algorithm, and I will also present results from generalized dynamics models. With that, we predicted item success. And we go right into it. It was we found for the item, for the first item, for the sprained ankle item, we could find 4 groups. And for the second item, we could only find 3 groups. What was very nice about this finding was that the average silhouette width were fairly high, higher than I actually expected, to be honest. And this indicates that we found substantial group structures here. To make it quick, the groups that we have identified mostly match the descriptions that we had expected. For the sprained ankle item, we did not expect that to find a second SL group, and we did not also not find the WE group. So people coming to an early decision, but focusing more more on the website. And in the prediction, here are also a lot of little gems to be uncovered, especially looking at evaluating the usefulness of information has an independent contribution in predicting item success when in the same model than reading skill. But let's focus here on the behaviors. And what we find here is that people were most likely to solve the item correctly when they were in the SL group or in the WL group. So that when they came rather late to their decision which page to choose. I have to speed up, unfortunately, a little bit. So let's make it quick here. For the book purchase task, we only found 3 of the expected 4 clusters. And something that I have to point out here is that the SE group is actually a little bit troublesome because, and this is something particular to the item or to the response format of the item. Here, it was not that you just indicated which page would be the best page, but you actually had to go to the page and click a buy button to solve the item. And since you might see it here in the SE group, since these people are actually very seldomly visited websites at all, they of course could not really press a buy button. And this is also something we observe here in predicting the item success. So what you might notice here is that the coefficients are extremely high. And what you can't see is that the standards errors are also super high. And which can be basically explained by the fact that actually, since people in this group did not really respond, of course, then there is not the possibility to give them a correct score. Okay, summing up, this work has basically lots of interesting findings, and one was very nice to see is that we could identify from the process data these substantial group structures, and these groups also combine time and navigational information, so which is pretty nice that we can describe here in a theoretical in a theory guided way different behaviors, and we find them actually also confirmed or supported by the data. What is also interesting is that we find similar groups, or at least groups that look from a behavioral point of view very similar across the items. Of course, with that exception of the second SL group in the sprained ankle task. And but yeah, there are still a lot of open questions. One I just mentioned about the SE group, and that there might be that it might not go very well together with the response format of the second item. Other things would be, or another question is, why didn't we find the WE group? And so here the idea might be, maybe these are simulation-based items, and so maybe the information space is just too small, and so we can't really observe that there isn't a WE group. But on the other side, it might be also just an irrelevant behavior, so something that we wouldn't observe in a natural setting, so working or searching with the real internet, for example. Last question here is especially when looking at the WL group, so people who most likely visited all the available information. So one could question if this is actually web search behavior, or if it's rather indicating a test taking strategy. There are other limitations that have to be considered here, but also many strengths. And I want to point out at least that at least in the web search literature, it's rather seldom that you have a study with multiple countries and that investigates a broad adult population. And so I just want to say personal thanks at that point to everyone who has made it possible to provide the PIAAC database, and because this is a very, very unique data set. So thank you very much.